Well, hey there, everybody, and welcome to yet another Ball Publishing webinar. I'm Chris Beatties, editor of Growertalks magazine, and I want to welcome you to what I think is day 297 of the stay-at-home order. I hope everybody's doing well. I know it just feels that way, but man, it's been a long time. But I'm going to be your host today as we tackle today's webinar topic. NF, and that stands for natural fiber wood products, improving the characteristics of growing media. Now, I've done quite a few of these webinars on growing media or wood fiber specifically, and maybe you've attended some of them. If you haven't, you can check them out on our on-demand archive area. It's the same place you sign up for our webinars. And it's a pretty popular topic because every grower out there is looking for ways they can improve their growing media or lower their input costs, or both. And the cool thing about wood fiber, from everything I've learned, is it seems to offer both of those benefits when done correctly, and with lots of positives and very few drawbacks, if any. But of course, I am not the expert, never have been the expert on anything, now that I come to think of it, except finding experts. And in this case, we had to go all the way up to Quebec, Canada to find today's guest. You're looking at him right there. He is Pierre-Marc de Champlain, the Technical Services Director for Berger, the renowned peat moss and potting mix company. Welcome, Pierre-Marc.
Thank you. Thank you, Chris.
All right. And you know what I'm going to do? I'm going to pop the next slide. In my old webinar days, before we had such good video, courtesy of Zoom and other organizations like that, this would be all we'd see of you. But now we get to see you live, so even more handsome in person.
I'm wearing the same shirt too.
That's right. Well, you got to be logoed, but there you go. But where are you broadcasting from today, Pierre-Marc? Because the fun of a webinar is you can do it from anywhere on the planet. You've got a halfway decent internet connection.
I think the bigger question is, am I wearing pants or not? No, I'm kidding. No, I'm actually
broadcasting. Go there, but none of my business.
I'm actually broadcasting from Rivière de Loup, which translates to Wolf River, which is about 2 hours northeast of Quebec City. So still a lot of snow. It actually snowed here last night, and we're getting to the spring eventually.
But you'd still be playing ice hockey if you were allowed to conglomerate together on ice, right?
Absolutely. Well, I'm not an ice hockey fan, but I'm sure a lot of my colleagues would be. Yes.
I was gonna say, you got some colleagues on this webinar. Don't let them hear that. Anyway, for me, I am broadcasting, well, not from my usual place. I've brought all that gear to my home office here in the western suburbs of Chicago, and I've got the comfort of all my wife's books here if I need research. If a cat strolls in during the webinar, that's Daisy. My sometimes secretary. Anyway, a couple of housekeeping things. First off, Caleb asked, when will we be getting a sandwich like that? That was a good looking bit of smoked meat there, wasn't it? I had one of those sandwiches down in Montreal once. They know what to do with some smoked meat. Unfortunately, no lunch included with this. That was going to be an extra $12, and who can spring that these days? But more housekeeping. If you have questions for Pierre-Marc as we go along, type them into the Q&A area, which Caleb has already found. I will, if they're kind of pertinent to what he happens to be speaking on at any given moment, I'll interrupt him and we'll field those questions. If not, we'll save them for the end because we're in a Q&A period. And if you have to leave the webinar for some unforeseen reason, or you want to rewatch it, share it with colleagues or whomever, it will be archived and fairly quickly. You can find the archive, the on-demand, as we call it, the same place you signed up for it, growertalks.com/webinars. And I believe that's all of my housekeeping. So Pierre-Marc, you set to take it away?
Absolutely.
All right, I'm gonna do two things. This is where it gets really fun. I'm now going to give you, let's see, I go up to here and I give you control of the mouse, and all you got to do is click on the PowerPoint. Take it away.
So just to test, I will switch slides right away, and it works perfect.
There you go.
Well, first of all, thank you, Chris. Thank you, Growertalks, for the opportunity to present some information on our on the NF Wood and our products. I'd like also to thank everybody for attending. Before I get started, I just wanted to, Chris mentioned I'm located in Quebec. I'm originally French-Canadian. My English is pretty good, but I still sometimes think in French and occasionally may be looking for my words. So please forgive me. So without further ado, let's get started with the presentation. So a little bit of an overview of what we'll be discussing today. First and foremost, we'll talk a little bit about the R&D that was behind developing the products that we have with NF Wood. We'll talk about the importance of high quality peat moss within or combined with NF Wood as a component. I'll do an introduction to the wood fiber itself, the NF Wood. We'll talk about the mixed characteristics, how wood fiber actually helps improve certain characteristics of the growing media. And I'll also provide some recommendations if you are making the switch from a given product towards a wood fiber or NF Wood product, what's important that you look out for. So in terms of the R&D, I mean, we did a lot of trials with wood fiber before we came up with the actual products. Oh, and I do have to warn you that I may have, and he's left now, I may have my 6-year-old, close to 6-year-old son come into the screen at some point, but I think he finds me too loud right now, so he's left with his iPad to go watch his show.
Daddy daycare. Everybody's doing it these days.
Yeah, we try to keep it to a minimum, but you know, kind of the situation. Let's just say we're very happy to have those iPads at certain moments.
You're never too young to learn about wood fiber and good quality peat moss.
Absolutely.
Get him started early.
In his case, I think the interest wasn't there, so he's gone to his room. So yeah, as I was mentioning, we've done many trials before we actually came up with NF Wood products. Our first products that we came out with, which was back in roughly 2012. We did a lot of trials with wood products. We tested a lot of different wood species, different types of fibers, different manufacturing processes as well. Trials that were done between 2008 and 2012. I was back then very much involved in the R&D. I was a project manager for the wood fiber project. So I you know, very much involved in the whole process. So obviously we tested a whole bunch of different crops, a wide variety of irrigation methods, environmental conditions, all that to make sure that the product that we were to launch would be adequate for all those conditions or situations, if you will. So I take the opportunity to let you know that since then, we have greatly improved our R&D capabilities. We did a huge investment. This was actually our new experimental greenhouse was actually opened, I believe, May last year. And it has 6 individual compartments or sections with independent environmental control. We've got a germination chamber, a lab, a lot of bells and whistles, and all that to be able to basically develop new products, do investigations on components, on different crops as well. So very proud to share this with you. And we're really happy about this, this huge investment that we did. So wood fiber's been actually a component that's been used in growing media for a long time. In Europe, actually, they've been using this component for decades. We were the first in North America to actually incorporate wood fiber into professional growing media for commercial growers. But as I said, it's based on a lot of research that was done in Europe, but we do have now a lot of research being done in the US as well. I'm thinking of, for example, Brian Jackson at North Carolina State University is doing a lot of work there. We also have seen work being done by Garrett Owen as well, Michigan State University, testing for various characteristics of the wood fiber, the physical characteristics, how it interacts with other components such as peat moss, the dynamics of the nitrogen immobilization of the wood fiber, how it decomposes, you know, especially pertinent for long-term crops, we're developing new products for specific market segments of horticulture as well. What's the impact of the wood fiber on the microflora in the context, for example, of organic productions? All subjects that we find very interesting, and Berger is very much involved and is doing its part in that research with our R&D facilities, but also through associations with various colleges and universities throughout US and in Canada. Really, the ultimate goal is to better understand this component and also the mechanisms behind those benefits that we have been observing over the years with the products that we have been selling, the NF Wood products that we have been selling. Because some of those mechanisms are, for example, we have observed a lot of rapid root development, and we do have our ideas as to why this is taking place, but we do want to really dig deeper and find out exactly what are the mechanisms behind that. So before we start talking about NF Wood, it's kind of, I would say, blasphemous to talk about growing media, not to talk about peat moss, because it is the backbone of most horticultural substrates. It's the main component used in a lot of the growing media that's used in horticulture. So I will take a few minutes to talk about peat moss. Obviously, peat moss has many of the desired characteristics for substrates. So that's why it's one of the main components and is typically the backbone of those growing media. It has adaptable chemical and physical characteristics, so we can adjust the initial pH and EC, electrical conductivity of the growing media. That's easily adaptable through the inclusion of lime and fertilizers. We can also tweak the particle size to get the desired porosity, water retention profile, depending on your application. It has outstanding water retention, up to 16 times its own dry weight in water. It's contaminant free. That's really thanks to the environment where peat moss grows. Peat moss grows in what we call bogs. That's an acid environment, not conducive to allow the growth of a lot of different types of species of plants. So sphagnum dominates in that particular environment, and it doesn't really give a lot of opportunities for pathogens and pests to basically establish in that type of environment. So when we go in and harvest the peat moss, it's already pathogen, insect, and weed free. As long as you manage it properly, once it's harvested, those characteristics are maintained. If the operations are done correctly as well, and if you monitor your harvested peat, you will have the presence of beneficial microorganisms. One that we have detected in our peat in the past is, for example, Trichoderma harzanium, which is actually the active ingredient in root shields. So as long as I said, it's managed properly, the temperatures of the piles are monitored to make sure that your peat moss is not heating out in the field, you will have those beneficial microorganisms in there. It decomposes very slowly. That's really thanks to, I guess, more the chemical characteristics of the peat fibers themselves, but I won't get into too many details there. Can be compressed and expanded easily, which is obviously a big advantage, with such a large territory in Canada and the US. The fact that peat moss only grows above a certain parallel, which is why you can't harvest peat moss in most of the United States. There's a couple of bogs there in certain areas. We ourselves have a lease for a bog in Minnesota. But typically it's more in Canada that you find it. So that means a lot of transport to get the product throughout North America. And the fact that it compresses and expands easily without damaging the fibers is a great advantage. So as I mentioned, the importance of peat moss is, and that, is basically based on the quality of the peat moss that is used to manufacture the growing media. And that's really based on the peat management system. So how you manage your peat, how you select the correct bogs to begin operations to harvest, how you prepare the fields for harvesting, how you actually condition the fields prior to harvesting as well, the harvesting operations themselves, how you store the peat out in the field, or how you package it when you actually process it. and the actual processing of it as well will all have impacts on the uniformity, the quality of the fibers, and all that is critical in order to obtain high quality peat moss and thus a high quality growing media. So one of the things that really differentiates Berger in how it manages peat moss is the fact that we have a very solid peat management system in place. We have a lot of off-season operations that take place to plan our future openings of bogs. We have pre-season, post-season preparations or conditioning of the actual fields to make sure that we can get into the bog rapidly once the harvest season begins. Continual peat reclassification done in the field. A lot of that is based on the density of the peat, and we don't satisfy ourselves with doing a quick observation at the beginning of the season, and we are constantly reevaluating each section of the bog to make sure that the peat is classified properly. The piles are covered, the temperatures are monitored. We manage our inventory very closely to be able to determine our peat blending strategies, I guess, in real time and on a day-to-day basis. And we try to do as minimal handling of the peat fibers to preserve the integrity of the fibers throughout the process. So a bit of a parallel on peat moss, which I found was very pertinent and important to keep in mind, that, you know, obviously wood fiber does provide a lot of great benefits, a lot of great advantages. However, it's not a magical component. And if your starting point, which is the peat moss, is of lower quality, well, yes, wood fiber can help you re-enhance and get some better characteristics, but it's not going to do the entire work for you. You really need to start off with a high quality peat moss to be able to get good results. So wood fiber really started through Berger's desire to always innovate, and also the concerns that Berger has always had on for the environment. So the goal of the wood fiber project, the NF Wood project, was really to look at renewable raw materials that could be used as a component to growing media. And what we wanted to be able to do with that component is to adjust and enhance certain growing media characteristics. But in all that, the final product really has to maintain the same quality standards as we do for all of our products at Berger. So that's really how the project started. There's a lot of different wood products out there that are available. I'd like to thank Brian Jackson for allowing me to use this image from a previous presentation that we did together at a different event in, I believe that was the ISHS event a couple of years ago. So a lot of different wood fiber materials are available out there, but there are nuances and differences between those different materials. And I did want to take the time to do a little bit of a comparison between wood fibers and wood chips. So both materials have similar characteristics in the sense that in both cases you can adjust the physical characteristics by adjusting the actual particle size of the particles per se. But that's really where the comparison kind of stops. Obviously, both will cause a little bit of nitrogen immobilization, but there are significant differences between both. The wood fiber will typically be more of a lightweight material, and once incorporated into the growing media, it tends to provide, yes, structure, but it's really a connective structure, as the fibers tend to really connect with each other within the growing media, helping, for example, the distribution of water and of the nutrient solution when you add it. The wood chips on their side are a little bit heavier, more dense. They do provide porosity and structure, depending obviously on the particle size of the wood chips that are being used, but they are more segregated, so they don't provide that connectiveness that the wood fiber does provide. So those products are produced obviously through different manufacturing processes. In terms of wood chips, what's typically being used is a hammer mill. So we have larger wood chips that are fed into a hammer mill system. The chips are actually struck by hammers rotating at high speed. the size of the screen holes in the hammer mill will actually determine the size of the particles. So as the hammers strike those wood chips, whatever particles end up being smaller than the holes will pass through, and the larger particles will stay in there until they get further broken down. Now, if we look at wood fiber, well, there's really two different types of processes, two main processes to manufacture wood fiber. So we'll look at both of those. Our NF wood products are actually manufactured through what we call the disc defibering process. And currently we have one main grade that's available, which is the horticultural grade wood fiber NF wood. But we also are working right now on products for a fine grade wood fiber for seedling mixes. Actually, we'll talk about that at the end of the presentation. But just to mention that right now we have trials going on with several of our customers to evaluate this new growing media and see how it fits within our customers' operations. So the double auger process is the other process that is mainly used to manufacture wood fiber. In this case, the wood chips are initially washed and fed into what they call a double auger system. You can see it at the bottom right. It's really two augers that basically will compress the chips and create abundant heat. And through that process, you will get what we call the double auger fibers. And those fibers are typically of uniform particle size, uniform physical characteristics. From my observations, there is a little bit more of a range, a distribution range of the size of the fibers. Let me word that a little bit differently. If you were to individually look at the different sizes of wood fibers within the product, you would see a lot more variation, well, a lot. You would see more variation with the double auger process than you would with the disc defibering process, which I will present in the following slide. So the initial steps are similar. The wood chips are washed. They're fed into the disc defibering system. The chips are actually preheated with vapor in a pressurized chamber. We're talking roughly 230 to 320 degrees Fahrenheit. The pressure that's applied is roughly 8 bars. In both cases, both the double auger system and the disc defibering system, you do have the possibility to color the wood fiber afterwards, typically using a natural coloring agent, which is included at a small percentage to basically provide some coloring to the actual fibers. Ourselves, with our NF wood product, decided to not include a coloring agent to our product for the reason basically that we didn't really want to hide the wood fiber in there. We're including it. We're not hiding that. So when we include it, you can see it. It's there. The other thing that can be done with both these types of fibers, I've seen it more typically with the double auger system, but you can actually what they call impregnate the fibers with nitrogen. So you basically add a nitrogen source to the fiber once the chips are defibered, and that is to help mitigate or reduce nitrogen immobilization throughout the use of the wood fiber within the growing media. So that's an option that certain wood fiber suppliers provide. Obviously, there's cost associated to that, and regardless, you can always add the fertilizer yourself in the greenhouse. So we do not add any nitrogen source to our wood fiber before we use it in our growing media. So in terms of what type of physical characteristics that the wood fiber provides to the growing media, it first and foremost, it helps with the wettability. I talked a little bit about the connectiveness of that fiber within the growing media. Actually, NF wood is made from the sapwood typically because it's a byproduct of the lumber industry. So the rounded edges of the wood is actually what is chipped to be used to manufacture the NF wood. And when you look at how wood grows, that external portion is really the live portion of the wood. And that's where most of the exchange from top to bottom of the trees takes place. So it does help improve the distribution of water, how water flows through the growing media, because of the fact that it's not hydrophobic. It won't repel water. Another interesting characteristic is the fact that when it's combined with high quality coarse grade peat moss, it does help provide good drainage, but it also helps increase the easily available water reserve in your growing media. That also means that if you are used to using maybe a more peat perlite mix, you may want to look at adjusting your irrigation frequency, especially during the initial irrigations. And I will get into that a little bit later, but just to mention that for a given growing media, if you're comparing it to a peat perlite mix, typically what a wood fiber mix will do is it will help with porosity, will give excellent porosity airspace, but it does tend to increase the easily available water in the growing media. It is an environmentally friendly alternative to perlite. I mean, we're talking about a component that, apart from the obviously the interesting characteristics that it gives to the growing media, there's other advantages to wood fiber, environmentally speaking. If you compare it to perlite production, the raw material, first of all, is a local product. It's available obviously in North America, whereas if you look at the ore of perlite and the ore of vermiculite, for instance, a lot of those ores are coming from other countries such as Greece, Brazil, Africa, Uganda being one of the countries where you can get vermiculite from. So when you consider that, where you get that raw material, obviously wood fiber is a lot more environmentally friendly because the material is simply closer. It's a byproduct as well. So it's not an operation that's being done to get that actual ore. It's a byproduct of another activity. So you're basically giving added value to a material that was, for all intents and purposes, garbage, if you will, for those producers in the past. The other thing I wanted to add in terms of that is that the manufacturing process is a lot more environmentally friendly as well. Less energy is required to get from the wood chips to the wood fiber versus perlite or vermiculite or even rock wool, which is a high energy process. So all that to say that much more advantages in terms of the environment with the wood fiber. Oh, I think I lost control of my slides. Give me a second. Oh, there you go. So just to give a little bit more of a visual aid in terms of how the wood fiber fits into the growing media. Now, bear with me here because with this whole virus situation, I actually had some difficulties giving instructions to our graphists as to how to prepare these drawings. I actually did some manual drawings myself with my son and sent those to our graphists. So it's probably not perfect, but it'll give you a good idea. So if we look at sphagnum peat moss, and let's say this is a typical profile for professional sphagnum peat moss. So you have smaller particles, larger particles, and let's say you were to saturate that growing media and after that allow it to drain. Well, you would obviously there's a lot of the water or the nutrient solution that will be retained within those fibers because of the advantages that I talked about earlier, the 16 times its own dry weight in water that it can retain. But there will be water that will be retained around the particles as well. All that water becomes, or at least most of that water becomes easily available water. And the larger particles actually help provide structure. So one thing that can be a bit of an issue with peat moss is the fact that on its side, it is hydrophobic. So it repels water unless you add a wetting agent. So that's where one of the advantages of wood fiber is that connectivity that I talked about earlier. So if we look at the wood fiber, we'll have the same saturation event, and then we'll have it drain. And yes, you are recreating some of those pores that you were getting with the peat moss, some of those macropores and micropores. In my experience, you'll get a little bit more micropores than macropores when you're using wood fiber when compared to, for instance, perlite or even larger wood chips. However, it does provide that connectivity. It helps with the lateral movement of the water and the nutrient solutions throughout the growing media. And so it definitely helps with wettability, helps keep a high water reserve, and that water is easily available to the plants. Now, if we compare that to wood chips or perlite, I split those in two. I guess I was sick of drawing on my side, and so I split those in two, so you can, because they, in all honesty, they kind of react in a similar manner in terms of going through the saturation and then subsequent drainage. And the major difference, well, obviously you can play around with the particle size of the wood chips to get either larger pores or more water retention. But what's interesting to look at here or to observe is you will note that on the wood chips, which is the yellow bits in the image, is that there will be water that will be retained around the perimeter of each individual wood chip. When you look at the perlite, well, once it drains, that perimeter of the perlite, yes, there will be a little bit of water being retained in those small pores that you see below the images that I have our graphist prepare. But overall, that perlite particle tends to stay water-free, and thus contributing a lot more to the porosity and the drainage of the growing media. So I hope that visual aid helped. I mean, obviously the images aren't perfect, but I hope it helped for those that are a little bit more visual than others. I myself am one of those.
Your son did very well with those, Pierre-Marc. We do have a quick question before we dive too much further into
sure.
the product. Adam wants to know what species of wood or woods you tend to be using, and does that matter? I
didn't mention. To be honest, we use pine wood, which is the species that is probably the most recognized in horticulture is pine. But we have done some tests on other plant species with excellent results. The reason why initially we ended up selecting pine is because it has a better reputation than other plant species, and because at the time wood fiber was very unknown in North America. We wanted to put all the chances on our side in terms of the acceptability of this component. I think now people are a lot more used to, as you mentioned earlier, there's been a lot of presentations on this component over the past years. And so I think now that it's a more accepted component in horticulture, I think that you will likely see different companies come up with other plant species being used to produce wood fiber. There are certain species that you don't want to get into. They will contain phytotoxic components that will be detrimental to plant growth. But there are other species that we have used in an experimental setting where we actually had very good results. And so, but pine in this case.
Okay. All right. No poison oak. While we got you on the line here, let's field another question from Bob. Does a natural fiber, an NF mix, wet up more naturally, or is a wetting agent just as important as with the typical peat and perlite mix?
So a wetting agent is always required regardless of the presence of wood fiber or not. The reason being, as I mentioned earlier, the main component is peat moss. Peat moss is a hydrophobic component. So unless you were providing the growing media at a initial water content above 55 to 60%, which is far from ideal in terms of transport, then when it's below that, that's when you have that hydrophobic effect. And so when you have that hydrophobic effect, you have to have an additive to help the water distribute itself throughout the actual growing media. So
the wetting agent is in there, in other words.
It is in there, absolutely.
All right, good. Carry on.
Okay. So let's look at the physical characteristics of the actual wood fiber. I think the most important one in terms of, or at least one of the most important benefits of wood fiber is the fact that it's extremely lightweight. So as I mentioned, Most of the growing media in North America, the main component will come out of Canada. There's a lot of transport involved. And so as much as possible, if we can keep the weight of the growing media as low as possible, that allows us to ship a lot more product per truckload. For those who don't know, there are limitations in terms of the weight of trucks traveling in the US, for example. And so it's important to keep our products as lightweight as possible so we can actually ship as much as possible. That's another reason why at Berger we keep our initial moisture content as low as possible as well. So if we look at wood fiber compared to other components, let's just look at the bulk density. The dry density is actually a different testing method, and you'll see that there's, in terms of increments, when you compare the dry density versus the bulk density, you'll see more differences for certain components on the bulk density. The dry density is measured with an actual weight through the FibSpan method, so we add a weight on top. The benefit of wood fiber is that it's lightweight, but it is extremely compressible. So with that method, you tend to overestimate the actual density. So that's why I also included the bulk density. And you see that roughly wood fiber, depending obviously on the manufacturing process and all that, but the wood that we actually use is very lightweight, 1.5 pounds per cubic yard. So if you compare that to peat moss, which is at 8.5, obviously all these values are subject to variations, especially the natural components in there, the sphagnum, peat moss, the wood fiber, and the wood chips. Whenever you're working with natural components or natural ingredients, obviously there's going to be some natural variations with those components. So there are some plus or minus with the values that I indicate here, but you see the great benefit or the great advantage in terms of weight reduction that the wood fiber actually provides.
And Joanne is clarifying that is pounds per cubic yard, right?
Cubic foot. Did I say cubic yards?
Oh, yeah. Oh.
I meant to say pounds per cubic foot, because if it was pounds per cubic yard, that'd be extremely lightweight.
Well, I was picturing a yard is about that. That is pretty fluffy stuff. Okay, so good catch, Joanne. There's got to be some prize, free sack of mix. Maybe.
Yeah, thank you, Joanne, for catching that. I apologize for making that mistake.
And Mark said the same thing, but he was a little too late to get the prize. Nice try, though.
So in terms of the chemical characteristics, if we look at wood fiber, it's a little bit lower than what you would want it to be in terms of a horticultural substrate. However, peat moss is a lot further than what the wood fiber is, and especially in terms of pH and EC, the beauty of peat moss and the beauty of wood fiber is that it is adjustable. So that's really we see peat moss and wood fiber as the blank canvas. And then you can go on and add the color that you want. So you can add lime to increase the pH to the desired pH range, and you can add fertilizer to increase the EC to the desired initial range. So, so those two characteristics are really the starting points. It's good to know, but in the end, all of that is adjustable and will be basically arranged to be in the right ranges for production. In terms of the CEC, which is the cation exchange capacity, that is actually something that will basically each individual component will contribute to the overall CEC of the mix. And if we look at peat moss, which already has a very good CEC, well, you could basically add on the CEC, depending on what percentage you're adding the wood fiber, you can add on that increment of wood fiber to the CEC of the peat moss once they're combined. So if you compare that to perlite, for example, which has a practically nil CEC, well, you get a benefit from using wood fiber compared to perlite in terms of that capacity. For those who don't know what the CEC is, I realize I didn't really explain it. It's the capacity of given components to absorb nutrients and then make them available to the plant. And so when you're adding your fertilizer solution, the peat moss will hold on to certain nutrients, certain cations, and then allow the plant to absorb those through the roots. So with perlite, not much contribution, but with wood fiber, a very good contribution. So in terms of the physical advantages of the wood fiber, I've mentioned this: low density, lightweight. That also means that you will get higher yields per bale with the products with wood fiber. The fact that it's lightweight, the fact that it's very compressible, allows us to put a lot more material per bale. So that will, in essence, reduce the transport costs. It also helps us optimize the water retention and porosity of the growing media. So as I mentioned earlier, one of the goals of using wood fiber was to be able to play with certain characteristics of the growing media and enhance some of those characteristics. And so the fact that it combines very well with peat moss and it creates kind of this unique soil structure allows us really to get to the desired or optimal water retention porosity structure characteristics that you want for your greenhouse. I mentioned this earlier as well, the connectiveness of those fibers within the growing media, which improves water distribution. And also, I mentioned this earlier, increases and stimulates root development. As I mentioned, we're not 100% sure as to what the mechanisms are behind that increase or stimulation of the root development. There's several theories out there. One theory that I have heard in the past is that the roots actually use the individual fibers as highways to be able to develop more rapidly in the growing media. I personally think that there are some more, maybe I wouldn't say, how could I put this without being judged? Basically, one of the theories that I have is the fact that when you look at the soil in the forest, for example, well, a lot of that soil is built on debris from trees and leaves and basically debris of dead trees or plants. And so when you're including wood fiber in the growing media, you're kind of, to a certain degree, copying that that environment, that natural environment where plants typically grow. And there might be some mechanisms behind that, some signals given to the plant, to the roots, that help it develop. But don't take my word for that. We're still on the research side for that. So just some theories that are out there. But that has been the general consensus with wood fiber, is that it does tend to stimulate the root development. Oh boy, I'm a little...
I just took control of your mouse, so you'll have to gain it back. I had to click through a couple of questions.
Okay.
There you go. Now you're good.
There are some disadvantages, at least one main one to the wood fiber, is that it is not completely inert. But thanks to the manufacturing process, the fact that there's a lot of there's high heat and pressure applied to the wood chips before it goes through the defibering process, it is very stable. So for medium to long-term productions, you will have, it will maintain some structure, but it will, like any other organic matter, it will tend to decompose over time. And that decomposition is really done by microorganisms that utilize nitrogen. So there will be some nitrogen immobilization. One of the reasons why we keep our growing medias with 25% wood fiber or less is that that's really what we felt was the cutoff where you growers wouldn't have to make any adjustments in terms of their fertilization practices with 25% wood fiber or less. We have seen through our greenhouse trials that if you're at 35% wood fiber or more, you will have that nitrogen immobilization be more prevalent, and you will have to make some significant tweaks or adjustments to your fertilization practices. Quality control. So that's, once again, very important at Berger, obviously, being ISO certified. So we also do a lot of QC testing in terms of the raw materials that we use. So before each production, we'll test our individual components and make adjustments to our recipes in order to make sure that the final product stays within the acceptance ranges that we have established. So here's an overview of our quality control system here at Berger. Obviously with the time, I won't go through each individual step, but you can see that it's a very simplified overview of our quality control from the peat harvesting, the quality control that's done actually out in the field before any peat actually makes its way into the factory, and then all the quality control that's done to adjust the particle size, and also done on the packaging itself to make sure that the yields that we are guaranteeing to our customers are contained within the units. And then once we use the peat, either in the bales or from the field to manufacture the mix, all the quality control that's done there. And I'll actually give you an example. For example, if we were to produce a BM5, now BM5 is a new family of products that we launched, I believe last year or the year before. I kind of lost track on time with this whole COVID-19 thing. But basically what we have is each individual component that you see on the left side of the screen will be tested prior to production in order to make adjustments to the actual recipe. So each recipe is not set in stone at Berger. So if we have a recipe for a given product, in this case BM5, before we reproduce that product, we will review the recipe every time to make sure that we make those small time adjustments so that the particle size, the chemical characteristics are maintained. Whether we're producing it in Quebec, in New Brunswick, in Texas, whether it's the winter, the summer, doesn't matter. We want to have those same physical and chemical characteristics. And then from that initial testing, once the recipe is adjusted, we run that through the factory. We do a lot of testing in the factory to make real-time adjustments. And from there, we get the final product. Once we have that final product, we'll do some sampling. We'll confirm that the nutrient content is good through the SME analysis. We'll confirm that the pH is good through 1 day, 7 days, and even 30-day incubated pHs. And we'll also maintain or retain warehouse samples of those materials or of those mixes in order to be able to go back. If ever we have a customer has an issue, we can go and pull those samples, do some testing, and really try to figure out what the problem is. So let's get to the actual products themselves. So one of the big advantages of these products, in this case, it's for the BM4, pertaining more to the BM4 and F wood, which is a peat wood fiber product. The yields are much better. You can get up to 13% more yield per bale. That means 13% more cubic feet per bale when compared to a more traditional peat perlite mix. We've had customers mention that they've had significant reduction in production time, up to 29%. Now, that's not a given. Obviously, it depends on what your starting mix was, what your production system looks like, or what your operation looks like. But there are potential gains in terms of reducing that production time. So just to give you an idea in terms of the yield, our typical yield in terms of a skyscraper is, let's say, 220 for most of our products. BM6 is one of our best-selling products. You see it there listed at 220 cubic feet per bale. Now, these are optimal yields. I just have to mention that once you receive your skyscrapers, we highly recommend that you adjust the moisture content to make it optimal for potting and to begin the actual production. So you basically will want to add roughly half a gallon of water per cubic foot. And so that will allow you to get up to optimal moisture content, which is between, I'd say, 55 and 65% moisture content. And with that, you will get that optimal yield, a minimum average of 220 for BM6, BM4 Euro, BM6 HP. Now, when you move towards the wood fiber products, that's where you see that increase in yield. So you'll have an additional 10 cubic feet with the standard BM4 NF wood. And as you increase the percentage of wood fiber in those products, you'll see that increase in the actual volume, usable volume for those products. So our BM4 NF wood family, we have different, we have a standard version, we have a high porosity version, the HP version. Both contain peat and wood fiber, a coarse grade peat moss, and a horticultural grade wood fiber. So all those two products were really made in order to give an alternative to the peat perlite mixes that are out there. It's not a true equivalent, as I've mentioned earlier. And so in terms of the water management, there are some adjustments that would be required. If, for instance, you are used to using a more Euro type blend, which is 100% peat moss, well, the transition is going to be a lot easier. For example, here, if you were to switch from a 100% peat moss to a 12.5% wood fiber or NF wood, in that case, the physical characteristics are relatively close, so you won't have to do any adjustment at all. If you do have to make some adjustments, it will be some very slight adjustments. But if you compare to a peat perlite mix, a BM6 for example, well, it is going to retain a little bit more water than your peat perlite mixes. So it's important to adjust those irrigation practices, especially during the initial irrigations. So once that, that root development, which as I mentioned earlier, happens rapidly, once that root development is there, once it's established, you can go back to your more regular or standard irrigation practices. The roots will actually help maintain the structure as well. And because they develop so quickly, they will have the capability to absorb a lot of water. So it's just important during the first initial weeks to keep a close eye. One of the things that can be misleading with wood fiber products is the fact that the surface of the media tends to dry a little bit more rapidly than the rest of the container. So I wouldn't base my decision-making on irrigation on just a visual checkup. I would actually take the time to lift the containers, check the weight, and base your decision more on the actual weight of the substrate rather than just a visual checkup. I'm kind of, just give me a second here. So as I mentioned, irrigation practices need to be adjusted, and that also applies to the high porosity versions of these BM4 products. And just a sec, I lost control again. What we typically recommend for those initial irrigations is really to, if possible, decrease the actual volume per irrigation and maybe increase the frequency. So instead of doing one big irrigation event, we'll spread those irrigations through several events, the same volume, but through several events, which will help make sure that the media doesn't stay too saturated when there's not a lot of roots in the media that are developed and ready to absorb that water. So we're talking the first initial weeks, and then once that's done, you're good to go. In terms of the fertilization practices, as I mentioned, we keep the percent wood fiber in the growing media lower to make sure that you don't have to make any significant adjustments to your fertilization practices. So if you're using the higher percentage wood fiber, you might have to tweak it a little bit upwards, especially if you're doing some precision fertilization. So you might want to do some slight adjustments there, maybe 10 to 15, up to maybe 25% increase in fertilizer, but that's really pushing it. I think that for most productions, a lot of the growers are already over fertilizing a little bit. So having the wood fiber in there shouldn't have a significant impact. But if you are one of those that is very precise in their fertilization, that's where you may want to increase it a little bit. This is actually results from a trial that Garrett Owen did at Michigan State University, and you will see that they actually used our BM4 product, the standard and the high porosity. They included different gradients of nitrogen, and you can see from the results here on both marigold and geranium that even though we have either 12.5 or 25% wood fiber in there, you see from those images and from those results that there wasn't a major difference in the fertilization practices. So it kind of backs what I was telling you earlier about not having to make much of an adjustment. But if you look at the lower side, that's where you see that if there are, I'm looking here at the BM4 standard, for example, or HP on the geranium side, you see at 75 parts per million, for example, you can see that the plants are maybe a little bit different. So for the lower rates, yes, you may want to increase, but as long as you're feeding above 100, you'll be fine in terms of the fertilization, depending obviously on the growth stage that you're at. This is the BM5 family. I'm proud to talk about this one. This is actually a series of products that we developed because we saw that for a lot of growers, it was a significant challenge to move from a peat perlite mix all the way to a BM4 NF wood, which has no perlite whatsoever. So a lot less forgiving when you don't have that perlite in there to help if you mistakenly over irrigated some containers. So this is really a transitional or an intermediate mix where you get the benefits of perlite, but you also get the benefits of wood fiber. And we have found that for growers that are interested in the wood fiber but don't want to go 100% to no perlite, this is a nice transitional mix to allow them to get used to the component in itself, and maybe they're happy with that and they stay with the BM5, or maybe then they convert to the BM4 NF wood. So we have 3 different options that are available: a standard version, which contains 15% wood fiber and 5% horticultural grade perlite. And then we have other increments of perlite and wood fiber. So a 20% wood fiber, 10% perlite, and the Super HP, super high porosity, which actually contains 25% wood fiber and 15% perlite. That Super HP, that one was really developed more for those very water sensitive crops. For example, succulents perform very well in that Super HP product. So that one wasn't not so much for a transitional mix or an in-between mix between that BM6 peat perlite and that BM4 peat NF wood. That one was really to give a mix with a whole bunch of porosity for those highly water sensitive crops. And a new product that we're currently testing with various customers, not fully available yet, but it's in the pipeline. We've had some great results internally. We've already done a lot of testing in different territories, notably in Latin America, certain portions of the US as well. We've had great results up until now, so we're confident that we'll be able to launch this product within the next couple of months. It's designed with our high quality fine grade sphagnum peat moss combined with a finer grade of wood fiber, and specifically designed for seed germination and plant propagation. So looking forward to having growers around North America test this product and see the benefits of wood fiber, not just in larger containers, but also in seedling trays.
Yeah, that was interesting, Pierre-Marc, because in all the webinars I've done, people have asked about what about filling plug trays, and a standard wood fiber mix just won't get down into the cells appropriately. So you've gone to a much smaller, finer fiber to allow that to happen.
Exactly. There are still some challenges, and that's why we're not preemptively launching this. We want to make sure that we run this product through all the different potting systems that are out there, tray filling systems that are out there, make sure it flows properly. One of the challenges, I think, has been the dibbling side of things with the wood fiber. Adjustments may be required in terms of the dibbling. The rounded dibblers tend to press down. That's where having maybe a sharper dibbler allows you to pierce that connective structure created by the wood fiber.
Which tends to be kind of spongy in a way, right? So it just presses down and springs back up.
Exactly. So the finer wood fiber allows us to prevent a little bit of that. And we also wanted to make sure that it not only worked well with the machinery to fill trays, but also sowing the seeds. But the other thing is, the paper pots. A lot of paper pots systems are out there. A lot of interest in that. The benefits of those paper pot systems are, obviously clear for growers. But we want to make sure that this component will also work well within those systems. So we've run some tests on that. we're still working further testing to see the different sizes as well. But from our preliminary testing, we're confident that it will work. One of the things that we were worried about is the fibers getting caught in with the knife that actually cuts the sausages, if you will, of paper. But with the finer fiber, we haven't seen that. So that's we're confident that that this product will also work with the paper pot system.
Okay, stay tuned for that one then.
Yeah, absolutely. But up until now, in terms of plant development, root development, plant development, we've had great results. The product, as I said, because it helps with the initial root development, that rapid root development tends to also keep the upper portion of the plant shorter and sturdier. So the energy of the plant initially, it seems to be concentrated on root development. So we maintain a smaller, sturdier plant. And once that root development is established, it's fully ready to basically concentrate thereafter on actual aerial development.
Right. And your slide says seed. Joe is asking, can it be used for cuttings, URCs? I would assume so.
Yes, absolutely. Most of our products.
Any propagation, in other words.
Yes, seed germination, plant propagation. Should have mentioned it there as well. But yes, absolutely. Once again, the challenge there is going to be in terms of inserting the cutting into the actual growing media for the same reasons we discussed earlier. As there may be some, you may need to adapt a little bit depending on the cutting that you are actually inserting into the growing media. The tools that you're using to make that hole, if you are using a tool. But yeah, I mean, there may be some slight adaptation, but absolutely, it will work great for propagation as well.
All right, you better wrap it up.
Yes. So, well, two final slides just to finally reiterate that we have a technical services team that is ready and available to help you basically make that transition into those NF Wood products. Help determine which one is better adapted to your actual production or your operation. So basically help with the initial assessment of the operation. What type of facilities do you have? What irrigation system you have? What crops you're producing, and kind of steer you towards the correct growing media within our large lineup of products. And then obviously set up trials to be able to test the material first, get comfortable with the material before you go full scale, large scale, and actually make the switch. And even once you make the switch, help support you throughout that process, either through our analytical services. If ever you're having any issues, they're available. Obviously that availability has changed a little bit now. Coming into the actual greenhouse is a big no-no for the moment. But there are tools now that we have. Obviously Zoom being one of them, Microsoft Teams, FaceTime, it's a virtual visit, but that can still help our grower advisor help you find solutions to any issues that you are having. And we can even offer training sessions through webinars to actually help your team adapt to these new growing media. So in conclusion, choosing the right horticultural mix can help increase the profitability of your operation. However, we understand that those changes in your growing practices do involve some risks and will take some adjustments. And that's why we've got a big support team. We have our direct sales team, which is a big family of close to 40, if not 40 now, salespeople that have actual experience in horticulture. But we also have our team of technical advisors in the field that can help you out. And we also have a team at the head office that helps support all that. That's really our main goal as a department, as a technical services department, is really for you to be successful, whether it's with our products, whether it's issues that you're having elsewhere in your greenhouse. We'll be very happy to help you out and make sure that you're successful in your production. Thank you very much.
All right, well, we've got a little bit of time for Q&A and a few cues here. Let me do this, and there we go. Let's see. Joe wants to know. You talked about decomposition of the
Yes.
fibers over time. He's wondering, is there a chance to see some decomposition and hence some shrinkage in a potted crop? Maybe a longer term crop.
I mean, yes, there will be some, inevitably, there will be some decomposition. I would say that we're not talking weeks, we're not talking necessarily months. I would say that it would typically take a longer period of time, more like 8 months before you even start seeing some of that decomp. And typically at that point, the root system is developed enough that the structure will be maintained by the root system itself. In terms of compression, the wood fiber is compressible in itself. So if you don't hydrate the growing media properly before you fill containers, once you water that, if you're watering from the top, you will, even if you have pre-moistened that growing media, you will tend to see some shrinkage or some settling being done on the growing media after those initial irrigation. So yes, some settling, not necessarily related to the structure of the wood fiber. And I have to mention that some of that, the rapidness at which the wood fiber decomposes is, I'm mentioning this through more experience than anything else, because we are currently doing some research in our greenhouse and in our labs and in association with universities to kind of pinpoint that with more precision, trying to figure out exactly at what point does the wood fiber start to decompose and lose its physical properties. And so we're doing work, internally, but and hopefully we'll have more in-depth answers later on for that.
All right. You kind of answered Lawrence's question because he was wondering why BM5 had perlite in it, but you could consider it a sort of a training wheel mix. Helps ease you into.
Yes, it helps also give more forgiveness to the mix in terms of additional irrigations that could be additional water that could be added during a given irrigation. Let's say you have one of your employees who's on the phone and he's talking away and he's drenching a container. Well, that's really the objective of perlite, is to get rid of that excess water. So including it in there helps get rid of the excess water. And as you mentioned, yes, training wheels to get used to this component, and make sure that if you do make the switch to peat NF wood, strictly peat NF wood product, that you're used to it and you know how to adapt.
Right. So maybe don't dive into the HP 25% right off the bat, and unless you're a real confident grower. Speaking of which, Bob wants to know what would be the minimum wood fiber. I'm going to guess 12.5%. Let's see if I paid attention. He wants to have a mix that's the equivalent of your basic all-purpose peat perlite mix. How much wood fiber would that have?
And that's a kind of a hard answer to give because of the fact that it really depends as well as on the peat that you're using, because a lot of that porosity and drainage that you get in both the BM4 and F wood, but also the BM6 peat perlite mix is through that coarse peat moss. But for identical peat, for example, you would probably have to get more up to the 35–40% wood fiber to kind of get close. But even then, it's never really going to give you the same physical characteristics. If we go back to that slide where I was presenting the profiles of the different components integrated in the grow media, that really helps understand that with perlite, as I said, water will just pearl off it. Pearl. Will kind of run off it, and you will immediately get that airspace back. Whereas with wood fiber, you will get airspace, but it'll take a little bit longer for air to get back into the mix because water is actually staying around each individual fiber. So you can add more, and that will help get closer to what you get with a BM6. But it's a bit of a difficult answer to give. Because of that.
Because they're not quite apples and oranges, but they're not apples and apples either. There's going to be some differences if you're using a wood fiber mix And you just have to be aware of that.
I may have some data. If there's any way I can get in touch with you, I may have some data on trials that we did in the past where we did different increments of the wood fiber and look at the physical characteristics. And I may have a closer number to give you.
All right. Joanne wants to know, do you recommend leaching, or don't you recommend leaching when watering?
You mean in terms of initially, or do you mean in terms of, well, let's say you've been producing for 5-6 weeks? I'll answer both. Initially, you don't have to leach. The wood fiber doesn't contain high salts, unlike, for example, core, where you can have some issues with if the core isn't conditioned properly, if it isn't washed properly. You may have to leach before you start using to get rid of the excess salts that are in the core. Potassium being an example of what can be massively released with the initial fertilizations if you don't leach it or clean it properly. If you have a reputable supplier, that shouldn't be a problem. Just to mention, I'm not bashing core at all. I think it's a great component in itself, but it does have that characteristics that if it's not properly managed, then you could have some issues there. In terms of during the production, it's like with any other growing media. If you are doing your fertilizations without allowing any leachate to come out, eventually the salts content will accumulate in there, and you're going to have to leach out any excess salts. One area where it tends to be more of an issue, more difficult to leach, is if you're sub-irrigating. Eventually salts can accumulate, especially at the top layer of your growing media. And when you're sub-irrigating, you don't necessarily have the capability to go in and irrigate from the top. And so that's where you might want to be careful and monitor that as well. Very important to monitor, both pH and EC.
Okay, sure. And speaking of core, coconut fiber, Dee wants to know, how do the two compare?
Wood fiber and core, it depends on the type of core that you're using. So there's a lot of different grades of core that are available out there. There's what we call more regular core, which is a finer grade of core. We also have core chips, which would be kind of an in-between of wood chips and peat moss. Actually, core chips, and you have my son here. Here you go. How's it going?
Are we having core chips, he says, Dad? That sounds tasty.
So I apologize. You know what happened is the battery for the tablet ran out.
The movie's over. That's okay. We're winding down here. We can be casual, Pierre-Marc.
So just to clarify, so in terms of the closest match in terms of the core, it would be what we would call the core fibers. So and it's not really a component that's used directly with horticulture, specifically with horticulture as a standalone product. You will have some of those core fibers, depending on what type of product you're using. You'll have some of those core fibers included within your core product, but it's I would say that core will be a closer match to peat moss than to wood fiber. Yeah.
All right. 2 more questions, then we're gonna wrap up. But I'll leave everybody with his address so you can answer your tough questions. Carl wants to know shelf life before you open the bag. You want to keep it in your barn for 10 years? Is that okay?
Like with any growing media that we offer, our shelf life is roughly 6 months, and it's not a shelf life where you'll have degradation of the components themselves. It's really the wetting agents that's the limiting factor. It is affected by high heat temperature. So basically, what you have is obviously peat moss and all those components aren't sterile. And so, well, wood fiber is after the manufacturing process, but once you incorporate it into that growing media, there's a microflora of microorganisms in there. And all they want to do is start decomposing stuff. And the wetting agent is one of those molecules that those microorganisms will go and attack. And once they basically break that down, you will have reduced wettability. That's the major issue there. So if you go past, oh boy, I think it's correct.
Is he okay?
Yeah, I think he tripped. So once you go past that 5 to 6 month, that doesn't mean that the growing media, the wettability will be completely gone, but you want to test it. So one easy way to test it is to basically grab a glass of water and grab a sample of the soil and drop it on top. And if the soil sinks in rapidly, let's say within 30 to 60 seconds, that means that the growing media is still safe to use and you won't have any major wettability issues. But if you drop it on top and it just sits there for over 2 minutes, that means that you will have to refresh that growing media with some wetting agent, which is typically readily available at any horticultural supplier. Simply follow the recommendations of on the bottle as to how to apply it to refresh that growing media, and you should be good to go.
Applies to any media you got sitting in a barn you wonder about, I guess, right?
Exactly. The other thing that will tend to go down a little bit, especially the nitrogen, is the fertilization. The initial fertilizer starter charge that we put in there, it's mainly the nitrogen that will tend to go down in terms of concentration as the growing media is stored. So I guess the nitrogen kind of gets goes through that nitrogen cycle and gets turned into basically N2, which is a gaseous nitrogen, and is thus not available in the growing media over time.
All right. And last one, and there's several questions here, so I'm going to ask you, first off, is the wood fiber, is it OMRI listed?
Yes, it is OMRI listed. I'm glad to announce that.
Do you have, or will you have an organic mix featuring NF?
We haven't officially publicized this, but we already manufacture some organic versions for specific customers that basically requested it. Yes.
Okay. So that leads to the actual question from Bob, which is, if you were going to do an organic mix using NF fibers, what wetting agent would you recommend?
So,
will we have a trade secret here?
No. We use a yucca-based wetting agent, which is the best organic wetting agent that we have found up until now. We are actually currently in the testing phase to evaluate a whole bunch of different wetting agents as we speak. It's, as I said, it's the limiting factor for our storage, so it's something that we're always trying to improve. But that's really been the best option available to us in terms of an organic option. And I'm not here to bash on anything, but with organic stuff, the advantage is that it doesn't stay long in the environment, right? So it doesn't pollute. The disadvantage is that it doesn't stay long in the environment. So
right.
The advantage kind of ends up being the disadvantage. So unfortunately, there's nothing yet that's available that's going to get to the same level as you would get with a more traditional wetting agent. But the yucca-based wetting agent that we use, I just don't want to use any brand names here because I don't want to I don't want to say that this brand is better than another. I'm going more with the type of extract that it is, which is a yucca-based extract.
I would imagine there probably aren't that many organic or OMRI-listed wetting agents to choose from anyway.
So. No.
All right. Well, thanks for the questions. I'm going to share right now. There's if you've got more questions, you can email Pierre-Marc at pmarkd@Berger, that's Berger, what I also could have had for lunch, .ca, because he's way up there in Canada. And the beautiful thing is he speaks French and English and Canadian. He's trilingual, so he can help you out with all your
I can speak some Canadian, eh?
I wasn't going to go there. And yes, this webinar, as soon as I can this afternoon, this webinar has been recorded. Is it recorded? Yes. Whew, it's recording. You'll be able to rewatch, share with your friends or what have you at growertalks.com/webinars, where you can also sign up for any future ones we have. I think there's some out there. And also watch some of the other archives, maybe some of the other wood fiber ones. And so that said, on behalf of, who am I thanking here? On behalf of Pierre-Marc and the fine folks at Berger, and for my stellar ball publishing staff. Hang on, let me click one more thing here. I want to say, my stellar ball publishing staff, who has spent so much time on Zoom with me. I think I've seen them more lately than when we actually go to the office. On behalf of all that, I'm Chris Beatty saying, so long, everybody, and thanks for joining us today.